Okay, we were here. You can have attention, please. I said look up, don't talk. Many of you came up to me last week and asked me this question. Why are we doing this? Understandable. You don't know why am I doing this. Okay, fine. Maybe I didn't set it. Okay, that's right. Chapter 10 is about curve sketching. And before we can actually sketch curves, we want to know, before we can actually sketch this curve, for example, we would want to know as x tends to infinity, that means this part here, that means very big, what happens to the y values? As x becomes very small, have attention please. I said look up, stop talking. We want to know as x tends to infinity what happens to y values, x tends to negative infinity what happens to y values, so that we can then sketch the curve properly. Follow? Now, no need to copy, you have already copied this part. Now, first then we say, oh okay, x tend to negative infinity, what happens? Example, negative 1,000, negative 10,000, negative 100,000, what happens to y? This is easy. This is easy because you look at it. If x is negative 1,000, negative 10,000, numerator is denominator. If x is negative 10,000, e to the power of negative 10,000 is a very small positive number. Right? You don't believe, you try on this. E to the power of negative 10,000 is a very small positive number. Which means I have a negative 10,000 divided by a very small positive number. Your number gets negatively large, if you want to put it that way. Okay, so negative infinity. This is easy. So we say, oh, okay, the general trend of my x is this way. That means as x tends to negative infinity, y tends to negative infinity. So far, so good. Now, next we want to see, oh, okay, as x becomes positive infinity, what happens? Then we, okay, fine, let's do this. X tend to positive infinity, y, which is equal to x over e for x, tend to what? This is tricky. This is tricky. Why? Numerator 10,000, big 10,000. Denominator e to the power 10,000, also big, infinity. Then we say infinity divided by infinity gives us 1. Correct? 2 divided by 2 gives us 1. 10 divided by 10 gives us 1. Negative 8 divided by negative gives us 1. So infinity divided by infinity also gives us 1. Wrong. Wrong. Why? I gave you the example last week. Remember? I said x over x squared or x cubed over x squared. So actually, this, if we write infinity over infinity, indeterminate. So we don't know. We really don't know. Whether it's infinity divided by infinity, 0 divided by 0, we really don't know what happens. Do you remember the example I gave you? Remember or don't remember? Example, let's say x over x squared. Does it mean that it's 1 as x tends to infinity? No. This thing will tend to 0. What if I add a cube here? What happens? Does it mean it's 1? No. As x tends to infinity, this whole thing tends to infinity. So you got a problem. So this is a problem. You see this, you must know there is a problem. Then we say, oh, okay, never mind. I don't like this. But you think about it. If I substitute x equals to 5, what is 5 over e to the power of 5? I substitute x equals to 10. What is 10 over e power 10? Obviously, if you key in your GCE to the power of 10 will be a lot bigger than 10. A lot bigger. E power 100 will be a lot bigger than 100. So we can quite safely then say that the denominator tends to infinity faster. It's a lot bigger. Then we say this tends to 0 plus. The reason why I put plus here is because it is a positive number. This can never be a negative number. Then remember in your notes, then I say, oh, okay, what can we interpret? We say, oh, as x becomes very big here, y tends to 0 plus. That's why the arrow is like that. So no matter what graph you sketch, the general shape or maybe the trend of y value should look like this. As x tends to 0. That's the reason why we do it. Okay, Ken? That wraps up what I said before we stopped last week. Okay? Ken? Okay.